In this video, I'm going to go over decision tree for capacity analysis. Decision tree is a schematic model of the sequence of the steps in a problem, including the conditions and consequences of each step. Businesses can use decision tree to help them decide which option to take for a certain project. It knows that there is a chance of outcome happening to help with the uncertain outcomes. It is possible to come up with the expected value. Decision trees help analysts understand the problem and assist in identifying the best solution. It provides a logical process for decision making. It is set out in a diagram that considers the times when decisions have to be made and where chance can determine an outcome. Decision tree use estimates and probabilities to calculate likely outcomes. Let's take a look at the example. The owner of Hacker's computer store is considering what to do with his business over the next 5 years. Sales growth over the past couple of years has been good, but sales could grow substantially if a major proposed electronics firm is built in his area. Hacker's owner sees 3 options. The first is to locate at a new site, move option. The second is to enlarge his current store, expand option. And the third is to simply wait and do nothing option. Remember, doing nothing is always an option for a business. The process of expanding or moving would take little time, and therefore the store would not lose revenue. If nothing were done the first year and strong growth occurred, then the decision to expand could be reconsidered. Waiting longer than 1 year would allow competitions to move in and would make expansion no longer feasible. In these 3 scenarios, the decision process includes the following assumptions and conditions. Strong growth has a 55% probability, so weak growth has a 45% probability. New site cost is $210,000. We also know about the payoffs from new site cost. We will have payoffs just in the case of a strong growth, which is $195,000, and weak growth, which is $115,000. Expanding current site cost is $87,000 in either year 1 or 2. Payoffs of the strong growth is $190,000 and weak growth is $100,000. The payoffs of the do nothing in the case of a strong growth is $170,000. For the weak growth in the $105,000. And then we can calculate the value of 7 alternatives over the next 5 years. As you can see in this table, column value shows the expected value for each alternative, calculated by revenue subtracting cost for each option. Based on this information, we can illustrate 7 alternatives using decision tree. What decision tree basically does is it assigns values to those options and determines which one is probably the best option for them. This decision tree maps out possible outcomes. For this problem, you need to know how to calculate expected value and then assess the net gains. We construct a decision tree to advise Hacker's owner on the best action. Decision tree use 2 types of nodes. In this figure, squares represent decision points, circles represent chance events. Branches from chance events show the probabilities for their occurrence. We draw the chance node or outcome node with respective states of nature or outcomes. Payoffs are placed at the end of the branches, as you can see. And then we can calculate the payoff amounts of 7 alternatives over the next 5 years. In this case, we have to understand conditional probability concept. This is a way of calculating the potential gains or losses of a project by taking into account several possible outcomes. So for example, possibility of outcome 1 times net profit or loss plus probability of outcome 2 times net profit or loss. When determining the optimal strategy for a decision tree, we have to start at the right and walk toward the left 1 node at a time in the sequence order in which they occur. So in this diagram, we can know the payoffs amount of 7 alternatives like this. And then we can compare each options from right to the left. When you look at the payoffs value of each alternatives, the largest one is do nothing that has higher value than expand, so choose to do nothing. And then expected value for the moving option, the probability of a strong growth times value for moving alternative, which is its revenue subtracting moving cost, plus the probability of weak growth times value for moving alternative, which is its revenue minus moving cost as well. That is 765,000 times 55% of chance of strong growth plus 365,000 times 45% chance of weak growth equals 585,000, which is smaller than the do nothing option. Similarly, we can come up with the expected value of each alternative. So in this case, do nothing has a higher value than expand option and move option. We need to choose do nothing alternative. And then ultimately do nothing option has a higher value than expand or move. So finally we should choose do nothing option for this project. Next we move on to the decision tree taking into account the net present value. This payoff value should be converted into net present value by taking into account the discount rate 16% in this case. I'm not going to detail for the net present value for this case. Decision tree analysis with the net present value calculations just discounted the expected value of our alternatives. But the decision that we made does not change. That's all for today. Bye guys.